My name is Lisha Malu and I am from KLE Institute of Technology, Hubli. I am studying in 8th semester in the Electronics and Communication branch. So most of us have faced an issue where we get spam calls or unknown calls from the unknown numbers, where we find it difficult to recognize whether it is a recorded call which has been recorded earlier and is just played, or there is a human who is interacting with us. So for this problem, I have created a solution which is human versus AI voice generation. In this project, my project is about detecting whether a voice or an audio is human voice or an AI voice. This is the dataset I have used for my project. I have labeled the dataset in two parts, AI and human. This is a multilingual dataset which I have created focused on 8 Indian languages. Those are Bengali, English, Tamil, Telugu, Hindi, Kannada, Marathi. So based on these 8 languages, I have created 300 samples for each of the dataset. The training code is done in Google Colab, where I have used CNN and OpenAI's Whisper model, which is a pre-trained open source model for language detection. This is my project where we have to install all the libraries. After importing the libraries, we mount it to drive where the dataset is being stored. This is the path of the dataset. After that, here the number of files which are in the dataset are fetched and all the data is being recognized. The files are here. After the files, we find it difficult from CNN to take the raw audio and look at that. So I have converted it into spectrogram. Spectrogram, which is based on Shannon's theorem. Shannon's theorem is like resampling theorem, in which the human voice is in the range of human speech is in the range of 0 to 8000 frequency, 8000 hertz. So using Shannon theorem, I have resampled those by multiplying it by 2, that is twice of the actual samples. I have resampled each audio to 16,000 hertz, and then the spectrograms are being created. The spectrograms are time versus frequency domain, in which all the languages, all the files are being created into spectrograms. This is the path of the spectrogram, which is also saved in Drive, which we will be using during training our model. The labels goes like, if it is a human, it is 0, and if the voice is AI, it is 1. Similarly, for all the 8 different languages, I have labeled it. After the labels, we can see that I have used 300 samples for each of the language, so it is 4800 samples. In the training code, we use NumPy to convert all of those to arrays, and then we use the layers, input layer, CNN layer, max pooling layer. Max pooling layer is basically the layer which is used to reduce noise in the any background noise from the audio. We have used sigmoid function here. After the training of the model, for voice detection, we use the OpenAI Whisper model, which is a pre-trained model. Here we have to put the path of our data set, path of our audio. After uploading the file, we get the result, whether it is which type of language it is, whether it is AI or human generated voice, and the transcription of the audio. For a better user interface, I have converted it into Streamlit, which is like this. Here we have two features. We can either upload our audio, or we can also live speech recording. This feature, we can record our speech live.
നമസ്കാരം, നിങ്ങൾ സുഖമായിരിക്കുന്നു എന്ന് ഞാൻ പ്രതീക്ഷിക്കുന്നു. നിങ്ങളുടെ ദിവസം സന്തോഷവും വിജയവും നിറഞ്ഞതാകട്ടെ.
I have uploaded a Malayalam voice. The prediction results are here. It says that it is an AI voice type. The language Tamil voice and it is human generated. And the transcription can be seen here. Similarly, we also have live speech recording.